In this video, we will see what is phase relation between EMF and current when capacitor is connected to an AC source. So students, we know about AC current and we know some important property of capacitor. So basically, while dealing with capacitor in second chapter, electrostatic potential and capacitance, we have seen that basically capacitor consists of dielectric, and dielectric have dipoles, means positive and negative charge. And for AC we have a positive half cycle and negative half cycle. So just imagine what will happen here. So when positive half cycle will come, so positive pole of the dipole will come to this plate, and when negative half cycle will come, then negative pole of the dipole will come to this place. Means if you look at this place, so this plate, so this plate become positive negative with very high speed, which matches with the frequency of this AC current. And if you look at this plate, same thing happening with this plate also, because suppose here is a one dielectric, this is positive and this is negative. So during positive half cycle, so this positive will get repelled by this positive half cycle and negative pole will come here, and during negative half cycle will attract this positive part of dipole. So this oscillation of dipoles takes place, and because of that there is current in case of capacitor connected to AC. While in DC after charging full, when capacitor get fully charged, so there is no current flow in the circuit in case of DC, okay, because of this charging, so capacitor become in steady state and there is no current. But in AC allow current, and it allow current in capacitor. So now we'll go for derivation. So we know that what is the EMF, what EMF will come here, E is equal to E0 sine omega t, okay, because there is no other component is connected, because only AC is connected to capacitor. So at any instant, potential difference across capacitor is equal to applied EMF. So we can write potential, that is V is equal to E, that is EMF in case of AC, so is equal to E0 sine omega t. So now students, we know that in case of capacitor, so V is equal to Q by C from second chapter. So therefore I can write Q is equal to CV, that is C into what is V? V is the E naught sine omega t, so E naught sine omega t. Now question is, why we are finding this Q here? Because students, so we have EMF and we want to find out the phase relation between EMF and current when AC connected to capacitor. So therefore if I have Q, so by differentiating Q I can find out I, okay, I can find out I. So current at any instant is I is equal to dQ by dt, that is d by dt of C epsilon naught sine omega t. Now this omega is multiplied with the variable, so will come out here omega, you can see here omega C epsilon naught, and differentiation of sine omega t is nothing but cos omega t. So I can write here I is equal to I0 cos omega t. What is I0 here? I0 is omega C epsilon naught, okay, this value I have kept here, okay. This become peak value of current in case of capacitor, जैसे हमने resistor और inductor में देखा था. Now I0 sine, now this cos omega can be written as according to trigonometric formula, cos theta is equal to sine pi by 2 sine theta plus pi by 2. So here sine omega t plus pi by 2. Now from this equation you can easily find out what is the phase relation between current and EMF in case of capacitor when connected to AC. That is, current is here actually leading EMF by pi by 2. What is the phase relation? Current is leading EMF by pi by 2. In case of inductor it was lagging, okay, or you can say in case of capacitor EMF is lagging by pi by 2, okay. So this is what phase relation. Now how we can draw waveform? It's waveform. So you have to draw one y-axis, and this is, let me draw it, and this is your time axis. Here you have to make time t or omega t, very important. And then our EMF is sinusoidal. I am writing here E is equal to E0 sine omega t. Now by looking both the equation, you can easily compare what is the relation between current and EMF. So let's draw sinusoidal wave. This is suppose one complete sinusoidal wave I am drawing, Okay, so here it will be 2 pi, and here it will be pi, and here it will be pi by 2, and this will be 3 pi by 2. So this is EMF. E is equal to E0 sine omega t, and you can see current is basically I is equal to E by R, EMF by R. So you will get something R here, that is called reactive capacitance. So current peak value of current will be less compared to EMF. So but it is pi by 2, it is leading. So when current will start from 0, okay, so it will start from maximum. Okay, so you can draw like this. It should be dotted line, and like this you can draw, and this is what your I is equal to I0 sine omega t plus pi by 2. This is what your current. And so this is complete graph. And how to draw phasor diagram? So simply draw x and y axis. I'm not using here scale, but in exam you have to use scale and pencil. And this is suppose 0, and first draw EMF line. It is at an angle omega t. Okay, so now this is peak value of EMF. Now you have to draw current. For current, so this is you have to draw one line. It should be perpendicular to this, that is 90 degree. So this will, and which must be leading. So here it will be your, and this angle will be pi by 2, and this is I. This is what you can write current, and this, let me draw this line. This is your EMF, and this is your I, and this is your phasor diagram. Okay, so this is what your phasor diagram in case of capacitor. So this is you have to draw. Now students, look at this term. I is equal to I naught is equal to omega c epsilon naught. Now if I'll compare this equation, suppose I am writing here, suppose I will compare this equation. I is equal to, this will be x-axis, I naught is equal to omega c epsilon naught. So according to Ohm's law, I is equal to V by R. Okay, so how much opposition this circuit will offer? So we have to convert this equation in terms to compare with Ohm's law. So what I can write here, I0 is equal to epsilon naught by 1 upon omega c. So see, again you will get same quantity, but from Ohm's law, from this I can compare that this R is, see this V is peak value, here you are getting MF. So this 1 upon omega c is equal to, that is opposition offered by the circuit. Okay, so by the capacitor. So you can write it here as, so 1 upon omega c. So let me go to the next new page. So this is what your opposition. So now, so I can write it here as XC, that is capacitive reactance. XC is equal to 1 upon omega c. This is the opposition offered by the capacitor. So, and you know what is omega? Omega is 2 pi into frequency into c. That is capacitive reactance. Okay. And students, so from this equation you can clearly see that capacitive reactance is inversely proportional to frequency. Okay, so if you will increase frequency, capacitive reactance will decrease. So for DC, if I'll compare with DC, so for DC frequency is 0, and therefore for DC X is equal to 1 upon 0, that is you will get infinite, means there is infinite opposition. That is important point, that is capacitor allow AC to flow through it easily but offer infinite resistance to flow of DC. So that is capacitor block DC. Okay, so this is what your capacitive reactance, and if you plot the graph XC versus frequency, so you will get this type of graph, exponential graph. like this. Here it is Xc and here it is frequency. So this is capacitor reactance varies inversely with frequency. Okay, as frequency increases, Xc decreases. That is capacitor reactance decreases. That is very important relation. Now students, one very important point in case of entrance point of view. Suppose I will connect capacitor to a DC source. This is capacitor, capacitance C, and this is DC source. Suppose its value is V0. Okay, and this is two plate of capacitor A and B. So what will happen when circuit will close? Suppose you have connected one ammeter here. Okay, so you will get momentary deflection because during charging of capacitor, but when capacitor gets fully charged, so you will not get any current in this circuit. Okay, initially what will happen? All electron will flow in this direction. Okay, because it is positive polarity here. Okay, and this plate become positive charge, and all electron will go to this part of the plate. So this plate become negative charge, and when capacitor gets fully charged, so there is no transfer of charges, and therefore there is no flow of current. Now if I'll plot the graph, if I'll plot the graph, students, that is how charges are increasing at this plate during charging, so you will get that you will get graph like this graph, and this is very important. Like this type of graph you will get, and here suppose here is the time and here is the charge. Okay, and time basically, so basically maximum charge on the capacitor plate will be, suppose here is the total charge, how many charge on the capacitor plate, that you can write down Q0. Suppose Q0 is equal to CV0 when capacitor gets fully charged. Okay, so now students, when you plot this graph, you will get this exponential graph. And what is important in this, so suppose in physics, what is this quantity will be called? RC. Okay, R is resistance, and C is the capacitance. So students, so when you will do dimensional analysis of this RC, resistance and capacitance, this is homework for you. So when you will get when you will find the dimension of resistance and dimension of capacitor, when you multiply, then you will get time constant, and therefore there is time axis. Okay, time constant. So how you can define time constant? So basically, so this is time axis. So if you'll walk on this axis, so you will get to one point where this RC, R into C, in terms of time you will get here. So this is what basically many times in exam it is question is asked, what is the which physical quantity you will get when you multiply resistor and capacitor? So answer is time, that is T. And that you can get by using dimensional analysis. Find out the dimension of R, dimension of C. Okay, and it will approximate 0.6320 टाइम Q0 टोटल Q का जितना वैल्यू रहेगा. सपोज हियर यू विल गेट मैक्सिमम चार्ज Q0 का 0.6320 part. So basically this is how they define time constant of RC circuit as the time in which the capacitor gets charged to 0.632 times the maximum charge Q0. Okay, so that you have to remember. So this RC will give you what time constant of capacitor, means how much time it will take to charge fully. So you can see when this line become parallel. Okay, so if you will draw one line, so this much time it will take to fully charge. यहाँ से लेकर यहाँ तक इतना जो टाइम होगा, that it will take to charge that capacitor fully charge. Okay, so this was all about capacitor AC circuit containing capacitor. Okay, and next video we'll do some important part of this chapter, that is Q factor. And thank you for watching this video.